Today, we're diving into something truly mind-bending, a brand new way to hide secret messages. We're not just talking about scrambling them, we're talking about making them completely invisible, hiding them in plain sight inside paradoxes that literally trick our own eyes.
Okay, so take a look at this. It's a classic puzzle, right? You have a bunch of shapes arranged into what looks like a triangle. Then you just rearrange them, and poof, suddenly there's a missing square. Where on earth did that empty space come from? Go ahead, take a second, see if you can figure out what's going on.
At first glance, this just feels like a clever optical illusion. It's the kind of thing that's designed to play on the assumptions our brains make about straight lines and perfect shapes. And yeah, it is a trick, but there's something so much deeper going on here. What if I told you that this little illusion, this gap in our perception, is actually the key to a revolutionary new way to encrypt information? What if the real secret isn't in solving the puzzle, but in the puzzle itself? All right, let's really get into how this works. We're about to see how this puzzle isn't just a puzzle. It's the key to a method where secrets are hidden not just with fancy math, but in the blind spots of our own perception. This method has a name that sounds like it was pulled straight from science fiction, the Singularity Cipher. And trust me, it's a totally new way of thinking about how we keep things secret. Okay, that's the official definition, but let's break that down. It's a hybrid system, which just means it does two things at once. First, the cryptographic part scrambles message to make it unreadable. But then there's this second part, steganographic. That's the real art here. It's about hiding the very existence of a message. It does all this using two layers, one built on some seriously weird math and the other on visual tricks. So here's how it works in a nutshell. You start with your secret message. First, it gets fed into the topological layer, which mathematically twists and scrambles it into knots. Then, that scrambled data goes to the paradox layer, which turns it into a series of visual illusions, just like that puzzle we saw. The final output isn't a bunch of text. It's an image. So let's look at that first layer, the topological twist. This isn't your standard encryption. This is based on a whole field of math that studies how shapes can be stretched, twisted, and bent without breaking. The whole idea gets its inspiration from one of the strangest objects in all of mathematics, the Klein bottle. Now, this is a theoretical shape that, get this, has no inside and no outside. The cipher basically simulates sending your message on a wild journey across this impossible surface, which is made by stitching two Möbius strips together. The absolute best way to wrap your head around this is with that classic Möbius strip analogy. Imagine an ant walking along its surface. The ant can just keep walking forever, and it'll cover both sides of the strip without ever crossing an edge, because there's really only one side. That's exactly what this cipher does to your data. It sends it on this completely disorienting path, making it almost impossible to trace back to where it started without the key. So once your data is thoroughly scrambled by that mathematical roller coaster, the really ingenious part begins, hiding it in plain sight with those visual paradoxes. And here it is. This is the secret to the entire system. The scrambled message gets turned into binary, a long stream of zeros and ones. A zero is represented by a normal, boring, geometrically correct image. But a one is represented by the paradox, the version with that impossible missing square. The secret message is literally spelled out in a sequence of these innocent-looking puzzles. This is what makes the Singularity Cipher such a game changer. It's not just about creating a strong lock on your data. It's about making the lock itself completely invisible by smashing together hardcore mathematical encryption with the stealth of steganography. This table really drives the point home. Just look at that visual concealment column. Traditional methods like AES are super strong, sure, but an encrypted file screams, "I'm a secret." Steganography can hide data, but computers are getting really good at sniffing that out. The Singularity Cipher is the only one that gives you both top-tier security and a kind of camouflage that's designed to be invisible to the human brain. And the real-world applications for this are just fascinating to think about. Imagine journalists in dangerous places sending messages that just look like simple diagrams, or artists embedding invisible, unbreakable watermarks into their digital work. You could even use it to add an extra layer of stealth to our most advanced post-quantum encryption, creating security that's not only mathematically unbreakable, but perceptually hidden too. This really brings us to a powerful conclusion about what the future of security could look like. It suggests we're stepping into a completely new era of cryptography.
For decades, security has been an arms race to create math problems that are just too hard for computers to solve. The Singularity Cipher changes the entire game. The new frontier isn't just about making the math harder, it's about creating messages that our own brains and maybe even AI won't even recognize as messages in the first place. The ultimate security isn't a lock that can't be picked, it's a door that can't even be seen.
And that leaves us with a pretty fascinating final thought, doesn't it? If a profound secret can be hidden inside a simple visual trick that we've all seen before, what other secrets might be encoded all around us, just hiding in plain sight, waiting for the right person to see them?